Alrighty, kiddos, let's learn about linked lists today. What is a linked list? Let's start with that. So, a linked list is essentially a data structure that is basically a list that is linked like a chain. So, they're used to get past the fact that arrays in other languages like Java, C++, C#, and all those object-oriented / low-level languages have statically sized arrays, meaning when you instantiate, for instance, when you create or initialize a new array, in Java, the format is you have int, you have your array, you have square brackets, not square. Array equals the new keyword here. Then we do int array, the size of the array, and that with a colon, right? So the size of the array is 8 in this case, meaning that the maximum items are 8. So if we go to 9, it will error because we can't have 9 items. So to fix that, we have to dynamically size it by taking our old array and copying it to a new array. So we'd have to do new int, and we'd usually double the size, 16. And this old array would have to be copied into that new array. Now that is a problem because we have to iterate through everything in the array on O of n time complexity to essentially solve this problem. Well, linked lists basically avoid that whole issue. They don't actually have a size limit unless you have a very limited amount of memory. In this case, we can create a linked list and connect pointers. So for instance, the first index would actually be the value like this. It's a box, and it would have a pointer to another box or another value in memory holding another value. And the list would kind of just go on like this in a chain sort of fashion. 865, right? Now, there's no size limit to this. We could go on literally forever if we wanted to. We don't have to worry about the size. How much, we have to worry about the space we're taking up, but it's not relevant if you're allocating memory correctly. So if we want to quickly not worry about dynamically allocating or dynamically sizing the array, we could just use a linked list. So how does that work exactly? So normally you would have a node. In this node, I'm just going to do this. I'm going to make a struct. That's a C++ notation. And inside of here, we're going to have a value called data. And next. Right? So now we have a struct with data, and they both equal to null. My handwriting is horrible. Y'all should probably get used to it. That's why I'm a software engineer, not a writer. So the question is, well, how does this work with this? Well, each one of these is a node. This chain here we see connecting them is the next part of the structure, right? This object here, this reference here, and then the data is actually what the value of that box is. So this data is equal to 8 in this case. So we'd create a new struct, we'd instantiate a new node for every single time we add to the linked list. So the language I'm going to use to do this and implement this data structure is going to be Lua. And we're going to use a module script. Give me a second to move this drawing pad out the way. And we're going to go ahead and create a linked list. So this linked list here is going to be a metatable. If you don't know how metatables work, I have multiple videos on them. This video is to explain how to make a linked list, not how this code works. We're going to create the basic standard template for creating a metatable. We're also going to create a function to make a new node. And we're going to return a blank table holding a value of data, as well as the next, which is of course going to be nil because we haven't added the next value yet. So when they instantiate a new or they call this constructor, we're going to call set the new node. We're going to set the head, because that's the first node. In this case, the head would be 8. We're going to set the head equal to the make node function, which will return that new table. So then we're going to make a few functions. We're going to call append, that'll add something to the front, and append to index, that'll append to a certain point, function append to end. That'll append to the end of the array, or linked list. Then we're going to add remove index, and then we're going to add print list. Now we're going to add a length property to this, and this will signify how many items we have in the array. Now the first thing we want to do is pass data through, and we're going to make a new node. And we're going to say make new node, and we're going to pass data through. So then we're going to go ahead and capital D for data. We're going to say, okay, well, we need to make the new nodes next. So new node dot next, it has to equal head, self dot head, right? And then we're going to set self dot head equal to our new node. So that'll essentially make our new head. This will add to the front of the, or append to the beginning. What this looks like is essentially we create a new value. I'm writing with my mouse now. And we basically replace 8 with this and set this next to the head. And this is now the new head. I can't draw with my mouse, but you guys get the concept. Now append to index is going to take a data. It's also going to take an index, which will be a number. And we're also going to add self.length plus equals 1 to the length. So now we need to add a conditional here. We're going to say if index is equal to 0, or index is less than or equal or greater than or equal greater than the length, so self.length of the linked list, then we're going to return a warning, and we're going to do string.format. We're going to format a string, and we're going to say a number less than, greater than 0, but less than, format the integer, got formatted integer. And we're going to say self.length and index. We're in that conditional. So then what we're going to do is we're going to make a new node, is make node, and we're going to say data. And then we're going to set the new node. Actually, we have to traverse the array. So we're going to traverse. We're going to start at index. While index is greater than 0, we're actually going to decrement the index. So index minus equals 1. And we're going to say that we need the value of node. We have to save 2 pointers or references to variables here. We're going to have last node and current node. The last node is nil, and the current node would equal self.head, because that's where we're starting. So then we're going to say current node, or last node equal to current node, and next current node equal to current node.next. So once that's done iterating, we can go ahead and say our new node.next next is going to equal to our last node, no, our current node, right? And our last node.next is going to equal to our new node. So we just basically inserted in between 2 indexes, right? Let's see what that looks like in our template. We make a new square, our new node, and we inserted that here. We set the next from 5 to here and the next to the next, the current. So we basically did that. We inserted in between here. So now this object would replace this chain here. So we just set the next of 5 to the new node, and we set the new nodes next to the next node. That's all we did. So the append to end, of course, this will take data, which will be any, and any type, because Lewis dynamically typed, we can get the current node equals self.head, and then while the essentially we need to traverse the entire array, so we'll say while current node is not equal to nil, current node.next is not equal to nil. What we need to do is iterate. So we'll say current node equals current node.next. After this loop is done, we assume that we're at the end of the entire linked list, and we'll set the make a new node. New node equals make new node. We'll pass the data that we want to save to this node into there. We'll set the new nodes and the current nodes next equal to, because we know the current nodes next is equal to nil. We'll set the current nodes next to the new node. And now we add it to the end of the array or linked list. Now we're going to remove an index. We take the index, which is going to be a number. We have to say, okay, well, we have to check to see if the index is less than 0 or the index is greater than the self.length. Then we actually have to return something similar to this. So I'm just going to copy this code. We're going to say number greater than 0, expected, but less than length, got length. That will work. So that will not prevent us from running the program if we try to remove an index that doesn't exist. So first we have to do, we have to save a few references. We have to have the last node as well as the current node, right? The last node, of course, is nil, and the current node is going to be equal to the self.head. So we have to get the very beginning. We start at the very beginning. So then we'll do while the index value is greater than 0. We're going to traverse the array or the linked list. We're going to set the last node. We're going to decrement, and we're going to set the last node equal to the current node, and the current node equal to current node.next. So now once we're there, we're actually going to set the last nodes next to the current node. Because remember, we're setting it to the next node to the current node. So this will get the node that is basically where that is. And we can't actually set it equal to, yeah, we're good here. We have to set it equal to, greater than or equal to. We can't remove we can remove the last node actually. And then print, finally, what we're going to do is we're going to say local current node. We just start with self.head. And then we say while the current node is not equal to nil, we're going to set current node we're going to set current node equal to current node.next. And we're actually going to print out the value of the current node. So print just print current node.data. And that'll print out the data. And that's our linked list data structure. So let's see if it works. So we have our linked list equals require game.server-storage linked list. My linked list equals linked list.new. We're going to pass through 50 to start with. And then we're also going to call my linked list print list. Let's run the program and see what happens. So we print out one item. We have 50. Now let's see what the structure is. Well, we have 50. We have a head, and the length is currently 0, right? So we actually have to append the length. I forgot to add. The linked list is size is 1 here when we initialize it. We're essentially going to have to call this every single time we do that. Append to end, remove, we'll have to decrement it by 1, -1, and print list. There we go. So the linked list size is 1. Now we look at the head, the data is 50. Let's actually append to the front of the list. Let's see what happens. My linked list, append, we'll add 500. 500 will print first, 50 will print next, because our head is now 50 and we have the length of 2. Let's append to a specific index. We'll append to index. We'll pass the data, we'll do 25, and we'll pass to the index of 1. Notice that we placed 50 at the index of 1, and we shifted 50 back, and we shifted 50 forward. 500 back, 550 forward. Notice how the head is now still 500, right? Because that's the first item we added. We went to the first index starting at 0, so 0, 1. We shifted the next value up, and we shifted basically the last value back and placed them in between. Now we can also try to do my linked list. If we wanted to remove append to end, we'll do that first. We'll say this is 100. If we append to the end, we'll add it to the end of the linked list, right? Now, if we wanted to my linked list remove index, let's remove the first index. We notice that it removed, what did it remove? Let's see here. I don't think I got called. What is it? What node did it remove? Why isn't that working? That's strange. Like, okay, so it's printing out 500. So that's the node we're removing. Removing 500. So last node dot next equals current node dot next. There we go. That's a mistake on my end. I forgot to. We're assuming that the current node is automatically set. I shouldn't have done that. We have to set it to the next node because the next node is the one we're actually connecting it to. The current node is the one we're removing. So now if we attempt to remove the first index, or the head, we'll notice it says, yeah, bud, you can't do that. Right, because last node doesn't exist. So what we can do for that is add a conditional statement. We can say if not last node, then what we can do is say, we're going to add an else if here. Don't worry about printing the last node. We're going to say self.head equals self.head.next. And now we remove the beginning of the entire linked list. So now the head is now 25. Yeah, that's a linked list and the data structure and how it works. We're going to go ahead and upload this to my Roblox profile. We're going to say distribute on marketplace, allow comments, and yeah. I'll link this in chat, or just not in chat. I will link this in direct messages. I mean, not direct, bro. I will link this in my description, and you can message me in direct DMs on Discord. That's what I meant to say. Anyway, see ya, bye.